All right, this video is showing you how to graph a sine or cosine curve with an amplitude change. So amplitude means it affects the graph the way that a stretch factor did. Okay? So it's going to make the graph stretch vertically stretch like tall or squish it down smaller. So up or down, squishing stuff. It's also, you'll see that like a regular equation, it's in the front of everything. So the stretch factor or the amplitude is in the front. It's the front number. And amplitude is always going to refer to the distance something travels. So even if this was a -2 in front of here, we would say the amplitude is +2 because we're talking about a distance something travels. So whether or not there's a plus or minus, you'd say the amplitude is 2 either way. So we're going to fill out some stuff here. Amplitude is a 2, that's the number in the front. Period, we're going to talk about that soon, but that is just 360. That means how long does it take for a normal sine curve to go through the whole thing, or how long does it take you to ride the screamer all the way around once? So that's 360 degrees. The vertical shift is, there is not one. Okay, that would be the number. If there's a number on the end here, just like normally, a plus k value moves something up and down, so we'll just say none. So what I'd like us to start with is by graphing the starting points and then the rest of the x values. So we're going to start at 0, and our period means the distance. So the distance we have to travel is 360 degrees, so that'll be at the end, that'll be our stopping point. And we're going to have some spaces in the middle here, 3 spaces total, and we're going to fill those in. So half of 360, you can make a line here, is going to be 180. Half of that is 90. Since these are symmetrical, this is going to be another 90 degrees on this side of 180, which is 270. So that's our basic 5 degrees, and we need to know those values as well. So now I'm going to do the y part of this, and normally 1 and -1 are important points. And sine, you're always going to draw the sine curve or the cosine curve, whichever one it is here. I'd like you to draw that first. We can connect those with dotted lines. So sine is the height. So the height at 0, you're getting on the Ferris wheel, the height is nothing. So I'm going to put a point there. Height at 90, you're straight up above the center. That's going to be at 1. At 180, you're back on the ground level. This one, you're under the ground in the water, if you remember that screamer ride. And last is at 0. So I just want us to connect those with a dotted line. Okay, so now I'm going to show you how this amplitude affects it. We didn't do anything with the amplitude yet. So amplitude is like a stretch factor. And so we're going to multiply the y values by the amplitude. Okay. And this time, whether it's positive or negative, we're going to use that value. So if this was really -2, we'd multiply by -2 because that does something extra, and we'll show that in the next one. So with this example, our amplitude is 2, so I'm going to multiply all of these y values, so these heights on the graph, by 2. So starting at 0 times 2, that didn't move anywhere, so that's still at 0. Okay. +1 times 2, that's +2. So I'm going to change my graph here and make a spot at 2. Okay. 0 times 2 is still 0. -1 times 2 is -2. So that I got to extend that down a little bit. 0 times 2 is still at 0. So we're going to connect those purple ones. And those are really this graph of 2 times sine of x. So you can see it's stretched a little bit taller. It's twice as tall here and twice as low here. And the amplitude, again, is just the distance between the middle, or this is called the midline right here at 0, and then either the highest point, so that's a distance of 2, or from the midline to the lowest point, so that's a distance of 2. Okay? So again, it's talking about distance, but it affects our graph if it's positive or negative, but we'll still just say it's +2 for the amplitude here. So I'm going to get you started on the next one on the paper, or this is just a good example. So we have -3 times cosine of x. So this is cosine now, so different looking graph. But let's identify some things first. Amplitude is, we're just going to say +3, And let's maybe make a note that's going to have we'll just put a star there for now. And I'll tell you what that means in a second. But it's the distance it travels is 3 from top to the middle or from the middle to the bottom. But that negative means we can do something else, and you might know that. Period, still 360 degrees. Vertical shift, there isn't one. Oh, I didn't say the minimum maximum there. You can do that on the top one. The minimum is now -2, the maximum is now +2. Okay, so we're gonna draw our axes here, starting at 0. The period tells me the distance I have to travel, so from 0 to 360, that is 360. And I'm gonna label my important points here. These are always gonna be the same unless our period is something different. That's when they'll change. Okay, then I'm gonna do my y-axis, usually between 1 and -1 for cosine. And cosine starts up. And cosine is the horizontal distance. If you're on the screamer and you're right here, you are as far from the center as possible and on the positive direction. So we're going to start up here at 1. If you're at 90 degrees on the screamer, you are straight over the center. So horizontal distance between the seat here and the center is nothing. So that's why it's at 0. 180 degrees, you are as far from the center as possible, but on the left now, so that's going to be -1, back to 0, and this will be back up at +1. Let me just get that out of the way. All right, so we're going to connect that again. This is the regular cosine graph. This has nothing to do with the amplitude yet. Didn't do it yet. All right, so the reason I told you to put that star there is because the distance between the minimum and the midline, which is the middle, or the maximum and the midline is 3. The distance is 3, but it was negative. That's going to do something to it. If you remember in all the other parent graphs, a negative in front means that it's basically flipped upside down. So I just wanted to make a note that my graph should end up flipped from this. So it should be reflected, so upside down. So the top of it's going to be up here now. So that's just something to keep in mind. So our amplitude I'm going to multiply by, let me write it maybe down here, multiply by that -3 number. Even though we didn't write it down right here, we're going to multiply by -3 because this is just asking for the distance. Okay, so +1, which is our y value, times -3, that's going to be at -3 now. So I'm just going to, here's -2, here's -3. So down there. Okay, 0 times -3 is still at 0. -1 times -3 is now +3. So I'm going to extend this up here. So that moves up. 0 times -3 is 0, and 1 times -3 is down at -3. So this purple is our new equation, or the new graph of this equation. Right? The dashed one was just regular cosine without this -3 in the front. Now this one has -3 in the front, and see how stretched it is, and it's flipped upside down.